Okay, so let's see if you got this. What's our first thing that we have to do? I would usually define what x plus y has to be here. X plus y has to be 22. Okay? So now we can find the height. 9 over 12 equals what? Where'd the 912 come from? Slope. 912 slope. Equals h, which is my rise, over my run of 16. If I cross multiply and divide, I'm going to get h is 12 feet. So that means I can break this up into an A and a B. And I know that A plus B equals 12. So now what I'm going to do is I'm going to express x and y up here in terms of A and B, so I have a system of equations that's in the same, two equations in the same two variables. So I'm going to use this triangle right here, which is A and x. The 912 slope. 9 over 12 equals A over x. So 9x equals 12a. What am I going to do with that? Divide by 9 to get x equals 1 1/3 a. So that means I'm going to replace x here with 1 1/3 a. Now we got to figure out what we're going to do for y. So look at this triangle here, which is B and Y. Helps if I draw it the right direction, I guess, maybe. This is B, this is Y, and this is a 612 slope. 6 over 12 equals B over Y. 6y equals 12b. So obviously here I'm going to divide by the 6 to get y equals 2b. So y here gets replaced with 2b. So now I have this system of equations, two variables. I'm going to multiply the top equation by a -2. So that's going to give me a -2a plus a -2b equals a -24. Any questions where that red equation came from? Just took this one times the -2. So now we have 1 1/3 plus -2 is a -2/3 a. 2 and -2b disappear. 22 and -24 make -2. And we will proceed to divide by -2/3. Give us that a equals 3. So if a equals 3 and a plus b equals 12, b has to be 9. X equals 1 1/3 a. So 1 1/3 times 3 equals 4. So x is going to be 4. Of course, that tells us y better be 18, but let's double check it. Y is 2b. Well, b is 9, so 2 times 9 is 18. How many of you had 12, 4, and 18? How many of you have no clue how to get 12, 4, and 18? How many don't care anymore? We're going to talk about something a little bit different today. We're going to talk about variation. Variation is an extremely powerful tool in math. And what variation is talking about is how two variables, relate to each other. If one changes, how the other one has to change. The first type of variation we're going to talk about is the simplest type, called direct variation. And in direct variation, if one number gets bigger, the other number has to get bigger. If one number gets smaller, the other one has to get smaller. And direct variation can look one of two ways. It can either look like this. Y is equal to a constant times x. Or it can be the ratio of y to x equals a constant. Now with a little algebra, you can see how these two are really equivalent. Depending on how we're working with it, it's sometimes simpler to use one form or another. So for example, if you are told y varies directly with x, or as x, what that is telling us right there is the y equals k times x, where k is a constant. A constant, just a number. 5, 7, 24, negative 13, whatever. Well, let's look at some more information. Let's say we're still told y varies directly as x, or with x, and y is 36 when x is 9. What's this new piece of information tell us? Well, it tells us we can take this relationship y equals kx, and we can put in this single condition that y is 36 when x is 9. And now we can solve for k. So if we divide by 9, we get 4 equals k. So what that's telling us is the relationship here, it is y equals a constant times x, but now we know the constant. The relationship is now y equals 4 times x. So let's say we're told y varies directly as x, and y is 60 when x is 12. And given the additional command, find y when x is 17. So there's 3 parts here. First part, y varies directly with x. What's that tell us? Y equals kx. Second part, y is 60 when x is 12. What's that tell us? We put 60 in for y, 12 in for x, and we can solve to get 5 equals k. Which tells us that relationship's not just y equals a constant times x, it's y equals 5x. And then finally, we're asked to find y when x is 17. So we're looking for y when we put 17 in for x. What's 5 times 17? Y is 85. What do you think? Not too bad? Okay. Mind-numbing? This is actually really powerful in engineering or any sort of problem-solving application. If you know how 2 variables are related but don't necessarily know the formula that relates them, the equation, but you know they're related directly. Now, the one thing that's required is to have a common 0 point, that when one is 0, the other one's 0. If that's not the case, then you have to do some adjusting to it. But you can see here, I knew nothing about the relationship between x and y other than that they were directly related. One gets bigger, the other one gets bigger at the same rate. Or same proportion, I should say. Now I was able to find out for a specific set of conditions just having one initial condition. That happens a lot in engineering. You know the type of relationship, but you don't know the formula. So you look, you know that it's direct, so you take that generic direct relationship, take a measurement, take a set of conditions, plug it in, and see what that constant has to be. You might take a second set of conditions and plug those in and make sure they work with that same constant. And if they do, then you have a formula. If not, that means they don't have the common 0 point, and you got to adjust for that. We're not going to get into something as complex as adjusting for a common 0 point. We're just going to get into doing the direct relationship as simple like this, well, with a common 0 point. So notice I'm going to leave a little bit of space there. Now I'm going to have you guys try this. So y varies directly as x. And y is 42 when x is 6. Find y when x is 11. So give that one a shot. Okay, so where do we start? So our generic formula is y equals kx. What do we do from there? So 42 goes in for y, k times 6 goes in for x. Divide by 6. So 7 equals k, and then so y equals 7x. And then find y when x is 7, so y equals 7 times, or when x is 11, so 7 times 11 is 77 equals y. How many of you had 77? Let's spice this up a bit. So here, y varies directly with the square of x. How's that going to change life for us? It's y equals k x squared, not just x. Try to finish that problem off then based on... So what'd you get? So we've got 48 equals k times 4 squared, which becomes 48 equals k times 16. Divided by 16 gives us 3 equals k. So y equals 3x squared. Plug in the 5. 5 squared is 25 times 3y is 75. Let's talk about something called inverse variation. And actually, before I talk about inverse variation, I want to go back up here for just a second. You'll note, when we talked about this, we said this, there was this form here, y over x equals k. This can actually be quite useful for the last couple of problems we did here. Or at least for ones like this one, where we're looking for y. If I know an initial condition and I know it's just going to be a proportional relationship like this, bless you. If y is 60 when x is 12, I know that that's going to equal my constant. Y over x equals k. Well, I know the constant doesn't change, so I know that after we change the variables, it's still going to equal k, so we can just set up a proportion. So find y when x is 17. You can just cross multiply and divide. 16 times 17 divided by 12 gives us 85. Could have done the same here. Since they just vary directly, y is 42 when x is 6. Find y when x is 11. You can just do a proportion. 42 times 11 divided by 6 gives us 77 for y. Now when it's x squared, it's a little bit trickier. We could have still used that with this one, but it would have been 48 over 4 squared equals y over 5 squared, and you would have had to work with it that way. So that is a little bit trickier. But you can use proportions for direct variation. So most of what we've looked at so far has been direct variation. The slope of a roof. Come on. The bigger the run is, the bigger the height is going to be. That's a direct relationship for a given slope. The slope actually becomes your constant then. So what we want to look at now is something called an inverse relationship. In an inverse relationship or an inverse variation, when one number gets larger, the other number has to get smaller. Or when one number gets smaller, the other one has to get larger. One example of this would be electricity. If the resistance gets larger, for a given voltage, if the resistance gets larger, the resistance is going to get smaller. So anyway, our formulas for inverse variation is that y is going to equal to a constant divided by x. That's our first generic form. Or y times x equals a constant. Now before it was y divided by x, or the ratio of y to x was a constant. Now it's the product that's a constant. That's a very important distinction. When we go to do some shortcuts, that's the shortcut we're going to use rather than a proportion and ratios. So if we were told y varies inversely with x, and y is 7 when x is 9. Well, first of all, let's figure out what that's telling us. Y varies inversely with x tells us what? Instead of y equals k times x, it's y equals k divided by x. Then y is 7 when x is 9. Put in 7 for y, you put in 9 for x, and you find what? We're going to multiply both sides by 9, 63 equals k. So what we're getting here is y equals 63 over x. Good questions? So, let's say we're told y varies inversely as x, and y is 12 when x is 4. Find y when x is 16. Now, before we even start here, x gets bigger, what should y do? Get smaller. So we're going to start out here with this first piece. Y varies inversely with x. What's that tell us? Y equals k divided by x. Next piece, k over x, yes. Y is 12 when x is 4 tells us 12 equals k over 4, and then multiply by 4 to get rid of that 4 gives us 48 equals k. So that tells us that this is y equals 48 over x. Then what? We'll find y when x is 16. So y equals 48 divided by 16 is y equals 3. So let's have you guys try one. So y varies inversely with x, and y is 9 when x is 8. Find y when x is 6. Give that a shot, see what you come up with. So here, where do we start? Y varies inversely with x, so y equals k over x. Then what? 9 equals k over 8. Multiply by 8 to get 72 equals k. Which means y equals 72 over x. Okay, then what? 72 over 6 means y equals 12. Y varies inversely with the cube of x, and y is, oh, what do I put in here? Y is 27 when X is 2. Find Y when X is 3. Give that one a shot in your notes. See what you come up. Where do we start? Y equals K over X cubed, okay. The next step is 27 equals K over 2 to the third, which is K over 8. So we're going to multiply by 8. 216 equals K. So that tells us, so Y equals 216 over X to the third. And then find Y when X is 3. So it's 216 over X to the third, which is 216 over 27, which is 8. We've got 8. Cool. We're going to pause here. We're going to take a break. We're going to come back in 10 minutes. So at about 10:27, and we'll finish this roll. So we've talked about our direct variation and our inverse variation. Now, when we look at this inverse variation, just like we do with the direct, there is a shortcut, like this one here. We're given that Y is 9 when X is 8. Well, instead of being a constant ratio, inverse variation is a constant product. So Y is 9 when X is 8. It's not 9 over 8. It's 9 times 8 equals find Y when X is 6. So Y times 6. So here you would solve 9 times 8 is 72. Divide by 6, you do get Y is 12. So you get the same answer. So you can use that constant product to solve variation problems for inverse variation. The best example of inverse variation is a pulley. Or you could also use gears as well. But when I'm looking at these two pulleys here, which pulley has to be turning faster? The small one. So let's say that this is a 10-inch pulley and this is a 3-inch pulley. You said that the 3-inch pulley must be turning faster. Let's say the 10-inch pulley is turning 120 RPM. To figure out how many RPM the 3-inch pulley is turning, we use this idea of a constant product. This is inverse variation. Smaller pulley, higher RPMs. So I could either go through the process of saying, hey, RPM equals K divided by the diameter. So then I have 120 RPM equals K divided by 10. Then multiplying by 10 gives us that 1200 equals K. So then going back up and say, okay, RPM equals 1200 divided by diameter, and putting in the 3 for the diameter, 1200 over 3 gives me 400. So this has to be 400 RPM for the smaller pulley. Now, other way we could do it is like I just showed you, just do Y times X. 10 times 120 equals 3 times whatever that RPM is. And if you solve that, you're still going to get 400 RPM. You're saying it's 3 times 1200 though. Once you divide by it? This is 1200 divided by 3. It's 400. Yeah, the RPMs is equal to our constant divided by diameter, because the RPM is inversely related to the diameter. Because the bigger the diameter, the lower the RPMs. So we put in 120 RPMs for this times a 10-inch diameter. I understand those, but I'm talking about the quick version. The quick version? Yeah. Well, it's a constant. Remember, this is technically I should have done 120 times 10. Because this is y is the RPM, and this is x is the diameter. You know, y and x. So remember, the other version is just x times y or y times x equals a constant. So 120 times 10 equals a constant. Well, for the other one, the RPM times the diameter must equal the same constant.
Oh, okay.
So you can just do 120 times 10 equals x times 3 or 3 times x. You solve that for x, you get 1200 equals 3x divided by 3, you get 400 equals x again.
Okay.
Now there's something called combined variation we can run into, and that's where you have more than 2 variables, and obviously when you have more than 2 variables, they can't all be directly related. I mean, they can all be directly related to one, but then they end up being inversely related to each other. So we call that combined, sometimes joint variation. And combined and joint variation, the generic form is often listed as this: y equals kxz. So y is directly related to x and z, but x and z are inversely related to each other. But it's not that simple. We have to basically use our own kind of common sense to put them together for each different example. So we might have y varies directly with x and w, and inversely with p. If y is 3 when x is 6, w is 8, and p is 24, find y when x is 9, w is 16, and p is 12. I want you to just take a second and see what you can get out of that. Okay, so this first part here is the big one. Y varies directly with x. So y equals kx. And w, so times w. And inversely with p, so over p. How many of you had that much? Nobody?
No.
Do you see why it looks like that? Varies directly with x and w, so it's y equals k times x and times w. And inversely with p, so it's k divided by p. So from there, it's just plugging in numbers. Y is 3 when x is 6, w is 8, and p is 24. If you solve that, you end up getting k as 1.5. Correct? So y equals 1.5 xw over p. So y equals 1.5 times 9 times 16 over 12, which is 18. Let's give you guys one more shot at one like that. Sure. I know Drew is anxiously awaiting another problem to do over there.
Absolutely.
Okay, thank you.
You bet. Y varies directly with t and the square of m, and inversely with d. If y is 5, when t is 2, m is 3, and d is what do we want to put in here? 36. Find y when t is 5, m is 2, and d is 50. Where do we start? Let's just make sure you're starting on the right track here. So y equals k varies directly with t, so k times t, and the square of m, so m squared, inversely with d. How many of you got that? Almost? Okay, so let's leave you to go from there. So let's go from here. Next we have y is 5, when t is 2 and m is 3, and d is 36. So if we look at this, of course 3 squared is 9. Are you with me, guys? So we've got 2 times 9 is 18 over 36. Now what I would do to make it a little bit simpler on myself is I'm reduce the 18 and the 36, reduce the fraction, divide by 18, so you get just 1/2, or k over 2. Then I just multiply by 2 to get 10 equals k. So what I have now is y equals 10 times t times m squared over d. 18 and 36 cancel. Leave me with a 2.
Oh, I just divided it. You mean 0.5.
That works too. Then you can divide by 0.5.
Leave that there for you.
So now, put 5 in for t, 2 in for m, and 50 in for d. You get y equals 4. How many of you had y equals 4? 2, 3, 4. Cool.
Wait, what?
Y equals 4. 10 times 5 is 50, times 2 is 100, divided by, or times 4 is 200. There's a worksheet I passed out while we were working at the end of break here. On that worksheet, do it. Do the odds. On Thursday, we'll go over the worksheet. We'll take a quiz. And then you guys will be ready to start your unit test. It's only 6.5 weeks into the semester. It's time for unit tests.